Welcome everybody to Math 60 and this video lecture, which is section 5.3. Remember that 4.5, 5.1, and 5.2 have been removed from testable material. The homeworks are optional extra credit. I won't be asking you questions on the quiz or on the final. So section 5.3 is equations with two variables. So far, all our equations have involved one variable, something like 3x minus 5 equals 28. And if we want to solve, we'll be solving for that one variable, add 5 to both sides, get 3x equals 33, divide both sides by 3, and you get x equals 11. However, having one variable is limiting because in life, it is much more common to have relationships between more than one variable. I'll write that as two or more variables. Where there is a mathematical equation that relates them. For example, dividing $50 between two people, Xavier and Yael, then this relationship can be represented as the amount of money Xavier gets plus the amount of money that Yael gets has to equal $50. And we have an equation with two variables. And so we just use letters for both of those variables. There are other equations that involve two variables, like driving 100 miles at a certain speed takes a certain amount of time. And I could represent that with speed equals x and time equals y. And I know it's going to take, I'm going to travel 100 miles is going to be my speed times my time, because distance equals rate times time. So there are a lot of situations that involve two or more variables, and we're just going to stick with two because it kind of demonstrates how everything works. And we'll pull away from our specific examples right now and kind of get back to abstract examples. So here's an abstract example, 2x plus y equals 10. Right, I'm not saying it's Xavier gets twice the money that Yael gets, and there's $10 total. It's just 2x plus y equals 10. And what does it mean to find a solution to this equation that now has two variables. When it was one variable, it just meant solve for x, and then x was going to equal a number. But now I have two variables, so even if I got x by itself, there would still be another variable involved. What does it mean to find a solution to this equation? It means find a pair of values, an x and a y, that together make the equation true. So let's find a pair of values that solves. Find a solution to that equation 2x plus y equals 10. I think that x equals 3 and y equals 4 solves the equation. And to check, just plug the values for x and y into the equation. Two x plus y equals 10, x equals 3, y equals 4. I'm going to have 2 times 3, because that's the x value, plus 4. And a good way to do these checks is to, you can do them two ways. You can put an equal sign, but it's a good idea to put a question mark because we don't know yet. We're checking. And 2 times 3 is 6, so I have 6 plus 4, and I want to know if that equals 10. And yes, that equals 10. Little check mark tells me that I'm right. That's one way to organize your work. Another way I like to organize my work is to make kind of a table where the equal sign kind of goes down the middle. And so I know I need 2x plus y equals 10. And now I'm going to put in my x and my y. And so I have 2 times 3 plus 4 on that side, and I have 10 on this side. And then I'm just going to work down each side of it until I figure out that the numbers are the same or the numbers are different. The reason I like this method with that table is it can handle more complicated expressions. 2x plus y is pretty simple and 10 is super simple. But I could have one where there was like a 3 times a quantity x minus 1 plus 2 times a quantity y plus 7 equals 4x minus 13y. And that's a lot to carry around. With the table, I can organize both sides a little better. So I know that x equals 3 and y equals 4 is a solution because together they make the equation true. And I can write this solution well, I can certainly write it like I just did. X equals 3 and y equals 4. Nothing wrong with that. I can write it a little more compactly using what's called an ordered pair. Ordered means The order matters. And pair means, right, two numbers. And so my ordered pair is x comma y equals 3 comma 4. This is a really useful tool to keep track of two, and in fact, even more than two, but in general, to keep track of two numbers, to write it as an ordered pair. It's always helpful, and I'm going to ask that you always write it as x comma y equals the numbers and not just the 3 comma 4. Because if you just write that, I don't know 100% which one is the x. I don't know which one is the y. But I want you to write it as x comma y equals 3 comma 4. So is x comma y equals 2 comma 6 a solution? And so I will check it to this same equation, 2x plus y equals 10. So I'll use my table to keep track of things. X here is 2 and y is 6. And I want to know if that's 10. Yep, it sure is. This process is called verifying solutions. It's one of the skills that you'll be working on in your worksheet. You're given an x and a y, and you just want to know, does that pair make the solution, or does that pair make the equation true? Now, there's something really important to work out, or to point out. I have at least two solutions to my equation. X comma y equals 3 comma 4, and x comma y equals 2 comma 6. I have more than one solution. If you are solving an equation with exactly one variable, you only ever get one solution. X equals 11 is the only value that makes it true. It's the only solution. But as soon as you give yourself two variables, you nearly always have infinite possibilities for the solutions. In fact, you have to work pretty hard to come up with an equation that doesn't have an infinite set of solutions. For example, I already found two. Let's see if I can find another one. How about x equals -1, y equals 12, or xy equals -1 comma 12? A solution. Nobody said that my x value had to be positive, or for that matter, that my y value is going to have to be positive. So I'll set up my little table here. So it's 2 times -1 plus 12 on the left and 10 on the right, which is -2 plus 12, which is 10. Yep, it is a solution. There are an infinite set of solutions to an equation with two variables, unless you work really hard and build one where there aren't any solutions. Of course, there are pairs that are not solutions. There are ordered pairs that aren't solutions. Just like there are x values that aren't solutions when it's a single variable. So is xy equals 5, 4 a solution to 2x plus y equals 10. And so I verify, again, we're just getting a lot of practice with this verification with this specific equation. X is 5, so that's 2 times 5. Y is 4. And the right side should be 10, which is 10 plus 4 on the left, which is 14. And 14 doesn't equal 10. So x comma y equals 5 comma 4 is not a solution. It doesn't make it true. If we think back to the examples I had, I'm going to divide $50 between Javier and Yael. There are a lot of different ways to do that. For example, I could give Javier all the money, or I could give Yael all the money, or I could split it 50-50. So a question I might ask is, how do I decide how to split the money? How do I find a solution to this equation? So how do you build a solution to an equation with two variables? And there are kind of two different possibilities. The first possibility is if you already know one of the variables values, one of the values. So let's take our 2x plus y equals 10. And suppose I know that x equals 8. Well, if I know that x equals 8, now I can substitute x equals 8. And by substitute, I mean plug the value of 8 in for x. And let's see what we get. I have 2 times 8 plus y equals 10, which is 16 plus y equals 10. And now I'm back to one variable. I've taken something new, which is an equation in two variables, and by knowing a little information, I can get back to one variable. And so all I have to do to find the solution, to find the complete solution, I have to solve for y. So I take 16 plus y equals 10, and I subtract 16 from both sides. And so I have y equals 10 minus 16, so y equals -6. So my solution is therefore x comma y equals, well, you told me x was 8, and I found out that y is -6. And that's my solution. Let's practice that again. suppose we know that let's find the complete solution to 2x plus y equals 10 if we know that y equals 5. So we substitute y in for the equation. 2x plus y equals 10 becomes 2x plus 5 equals 10. And then we solve for x. So I'll subtract 5 from both sides, and I get 2x equals 5. Divide both sides by 2, and I get x equals 5 halves. Nothing wrong with the fraction. We've been working with fractions. And so that means my solution is the coordinate point, sorry, the ordered pair, x comma y equals 5 halves, comma 5. Another of my infinitely many solutions. Now let's talk about how to organize this information. Suppose I have a number of partial solutions. For example, one of my solutions, I know that x equals 3. Another of my solutions, I know that y equals 5. And still another of my solutions, I know that x equals 2. And in yet another of my solutions, I know y equals negative 12. And I want to complete all these different solutions and organize them. And the easiest way to do that is by using a table. So I'm going to build a table that has my equation at the top and then has an x and a y, which are going to be my solutions. And then I can input my partial solutions and come back and figure things out later. It doesn't really matter how I organize them. So I know one of my solutions, x equals 3. Another of my solutions, y equals 5. And I have a solution where x equals 2 and where y equals negative 12. And then I complete the table to complete the set of solutions. We already saw that when x equals 3, y equals 4. That was our first example. And we just saw that when y is 5, x equals 5 halves. We also did an example where x equals 2. And I think that made y equal 6. I haven't worked out the negative 12 yet, so I'll do a little bit of work on the side. 2x minus 12 equals 10. And I'll solve for x. So I'll add 12 to both sides. And I get 2x equals 22. And I divide both sides by 2, and I get x equals 11. And so now I can complete. And what I have is a set of 4 ordered pairs, but rather than list them one after the other, I just organize them in a table. It helps me keep track of the different solutions. So on your worksheets, you'll see a lot of things organized that way. Usually when you're asked to find a solution, you're given some information, but maybe you have no information. So that's our other possibility. And want to create a solution to, for example, 2x plus y equals 10. Well, step 1 is choose any value you want. Well, say, tell me a number.
6.
Okay, I'm going to say that x equals 6. And now we're back to where we were before. Step 2 is you now have a partial solution. So you take 2x plus y equals 10, and you substitute x equals 6. 2 times 6 plus y equals 10. And now we're back to a variable or single variable equation. So we solve that for y. 12 plus y equals 10. Subtract 12 from both sides, and you get y equals 10 minus 12, or -2. And so our solution is x comma y equals the 6 that Jose picked and the -2 that we determined y has to be in order to make it true. Okay. I just want to lay out some other examples of equations you might see. I did the 2x plus y equals 10 a lot because it was nice to use the same one, but they don't always have to be on the side. Same side. You could have 3y equals 5x minus 10, for example, where the x and the y are on different sides of the equation. Here the numbers over by the x. You could have fractions for sure. You could have 1/2 x plus 7 equals 4y. But the process is just always going to be the same. You have the x and the y multiplied by each other. You could have something like 5xy equals 32. Still, the process is going to be the same. And you can even have, although in this section we don't, you could have some pretty complicated equations. You could have something like 2 times x plus 1 minus 3 times y minus x equals 7 times y plus 4 minus 2x, right? Still an equation, still has x's and y's. This is still going to have all sorts of different solutions, and each of those solutions is going to be an xy ordered pair. So they don't always show up as simple as the 2x plus y equals 10, but the process is always going to be the same for saving them. And that's actually the end of this whole section. So I'm going to stop recording.